Hey everyone, I'm going to do a little bit of a screencast today, not on GraphQL or Immutable.js, but on a project called DataLoader, which is something that we built and released maybe 6 months ago. And it's not a JavaScript library that we use at Facebook, but it's a JavaScript port of a technique that we use on our servers at Facebook. I want to talk to you about it kind of as a prerequisite to talking about GraphQL, and I promise I'm going to do a video series on GraphQL as well, so look forward to that. But one of the techniques that we use to make our GraphQL implementation at Facebook really fast is exactly what you see in DataLoader. And if you happen to be familiar with Haskell, which is our Haskell plugins, or library rather, for Facebook, then you might have seen this technique before. Before I kind of go into it, I think it's kind of interesting to hear the story of why DataLoader exists. So my colleague Dan Schaefer and I were at Pinterest. We were meeting with some of their engineers, and we were talking through some problems that we had faced and solved in our servers that they were kind of facing right now. And we were discussing some techniques that we had used, and we were really hoping for like a dialogue between, ways that they solve their problems, hopefully different from ways that we solved our problems. And what we realized was there were a lot of ideas that we had that we kind of took for granted that were kind of surprising to them or things that they hadn't considered. And we were kind of wandering outside of the Pinterest office after that meeting and thinking, wow, that's really awesome. We should open source some of the work that we've done on our servers. And then we stopped to think, like, what even would we open source? Like, what is it that's interesting about what we are doing on our servers? And as we were just kind of walking along the street, we came up with the idea for DataLoader, and we actually hopped in a coffee shop, and Dan Schaefer and I sat next to each other for about an hour and a half, kind of pair programming, and we wrote the first version of it. And then over the weekend, I cleaned it up and put it on GitHub. And this library doesn't have quite as much awareness as Immutable.js or GraphQL does, and it's certainly nowhere near as large in scope as those other libraries, but it's certainly one that I'm pretty proud of. I especially like kind of its origin story. So let's jump in. What you're seeing here is the GitHub page for DataLoader, and hopefully this is a good place to start. What I want to do is talk about kind of what DataLoader is, what it's responsible for, and then we're going to do a little code splunking. We'll dig in and see exactly how it works. So DataLoader is a library that is responsible for batching and caching. These are two techniques that we use to make it fast to execute against our database backend behind our web service. And here's how those two techniques work. One is if you ask for the same piece of information in two parts of an application request, say one part of the web page is loading a newsfeed story that happens to be written by your friend and we want to show their name and profile picture, and on another part of the page or another part of the request, there's something in the sidebar, maybe a chat tab or something else that also happens to show the same friend with the same name and profile picture, we definitely only want to load that from the database one time. So that's where caching comes into play. The next is batching. So batching is important when you're going to fetch multiple things kind of the same kind that are going to come from the same database at the same time. And this is important when you have many pieces of code that are independently interested in pieces of information that are all kind of running at the same time. And a great example of this is newsfeed. So when you load newsfeed, first what you get is a bunch of IDs for newsfeed stories. That's fine. We can go to our newsfeed backend and say, given this set of IDs, we want data about all of those newsfeed stories. But then once we recurse into the newsfeed stories, it can start to get a little bit harder to fetch the information in a reasonable way. So we might get to the same example. We want to get the name and the profile picture of the actor of the newsfeed story. Now, it would be really nice to write some clean code where you might write something that gives you a promise for the Facebook user that you're going to get the name and profile picture from. But you don't really want to think about that as a property of fetching some number of newsfeed stories. You want to think about that as a property of fetching one piece of information in the context of a newsfeed story. And you can recurse down kind of deeper and deeper. That example is a fairly simple one, but you can get into this case where a newsfeed story may have an attachment that's an event. And that event might have people that are going to that event, and you might need their profile pictures. You might need to load those users. And kind of in parallel, in a sibling part of loading a page or a request, you're doing some other maybe totally unrelated piece of data loading. Maybe if we're still in our newsfeed example, a totally different newsfeed story is someone who's mentioned a couple of their friends, and we want to show their profile pictures as well. So we're in this situation where we might need to load users in all kinds of different unrelated parts of a request. And what we really want is a way to batch that stuff together. So DataLoader is the way that we do that. And essentially what happens is we take a function that, given a set of IDs or keys, will return to us a promise for a set of values. So we give an array of IDs and we get back a promise for an array of values. But what we really want when you're kind of building an application is an API where you give a single ID or a key and you get back a promise for a single value. And that's exactly what DataLoader does. So let's look a little bit more at the README file, and then we'll dive into exactly how that works, and we'll look at some examples. So one thing I want to say, and I'm proud of this, is DataLoader has 100% test coverage. And if you actually go look at the source, which we're going to do in a minute, you'll see that there's actually way more lines of code written for tests than there are for the actual source code. And you'll find the source code for DataLoader is not that large. It's a couple hundred lines. Most of that is comments. And that's on purpose, because what we really hope is not that, if you use JavaScript, that you'll use DataLoader, but we recognize that lots of people have lots of different kinds of backends, some in Java, Scala. Ours at Facebook is written in Hack, which is a derivation of PHP. And this technique should work kind of equivalently well in all these environments. We hope this is kind of a reference implementation for this idea. Here's how we get started. We might do a little example later if we have time. One thing to point out is DataLoader assumes an ES6 environment. If you're running the latest version of Node, you're good to go. But if you happen to be running an older version of Node, then you want to make sure that you add promise and the ES6 map. We use both of those in the implementation. So here is an example of DataLoader at work. To create a DataLoader, you want to provide a function that's your batch function. So what you're going to do is provide a batch function that's responsible for going to the database and doing whatever needs to happen. And that's going to take in the array of keys and return back the promise for the array of values. And DataLoader is going to do the job of splitting that into the interface that we actually want to give to people. So in this example here, we don't know what this function does, but it's going to return to us a promise of an array. And what that gives us, this user loader function here, is something that we can then call .load on it, and we can give it an ID, and it's going to give us back a promise for a value. And we can do this kind of in multiple places in our application. So we might call here load at ID 1 here, and load at ID 2 at another point in our application. And if these two things happen in a single tick of the event loop, and I'll talk a little bit more about exactly what that means, then they're going to get batched together. And when we call your function here, keys is going to be the array 1, 2, and you're going to return back a promise of an array of two things that are going to be the two values that represent those keys, 1 and 2. That's bashing. So caching is a little bit simpler. Caching just means that if you load the same key 2 times, we're only going to request it once. And that works kind of regardless of at what point in the process the first request is going out. And in fact, in this example, we're loading the same ID twice in the same frame of execution. And not only is it going to return to you the same value, we're actually going to give you the same promise for the same value. And that ends up being nice if you want to memoize on the actual promise itself, rather than waiting for the value to come back to determine if these two things are the same. So here's the API for DataLoader, and it's really fairly straightforward. Most of what's going on is that you're going to construct a DataLoader given one of these batch functions. And as I talked about before, the batch function accepts an array of keys, returns a promise for an array of values. And there's also a handful of options that you can use here, and they're fairly straightforward. You can turn batching on and off. You can turn caching on and off. And you can provide a custom cache key function. So this is pretty important when your key is something other than a scalar. I found that most of the time you're using a string or a number as your key, but in some cases, and I believe MongoDB is an example, you're actually going to want to use like an object with a key in it that represents a key object. And you need some way to determine if two are the same, and we want to turn that into a scalar. So cache key function just lets you do that. And cache map, this is the actual cache that we will use. So if you don't provide one of these, and most of the time you won't, we're just going to use ES6 map as your cache. And there's some trade-offs for this. One of the trade-offs is that you never delete anything back out of that cache. So this cache infinitely grows until that data loader gets thrown away and is garbage collected. This could be the right approach if you're loading stuff like we load stuff at Facebook, where we create a new data loader on every request, and it's only responsible for the batching and caching relative to that single request. And once that request is sent out to the client, we throw it away and it gets garbage collected and we can move on. If you're building something that's longer lived, you might want to provide like an LRU cache or something like that. Here's where you do that. Once you get back your data loader, there's only really a few things that you can do with it. You can load a key. You can load many keys, which is really similar to calling promise.all. And you can clear a key from a cache. And that's important if you have mutations happening and those mutations need to invalidate a cache key. You can do that. And you can also clear an entire cache. And that's it. That's the entire API. So it's really fairly straightforward. And there's even a section here on GraphQL. I won't go into this too much now, but in a future video, I'm going to talk about GraphQL and how GraphQL works under the hood. And hopefully then it'll be more clear why I wanted to talk about DataLoader first, and we'll refer back to that. But suffice to say, GraphQL is often going to be calling things that return promises, and it's going to be really helpful to batch and cache those things to ensure that we have a really performant GraphQL server. Skipping past that. As you can see, the README is fairly comprehensive, and even at the bottom, and I won't spend too much time on this, but at the bottom there's a list of kind of code to get started for really common backends. So there's some example code here for Redis, for CouchDB, for SQLite, and one thing that you might notice here is that most of these are fairly short. This one for CouchDB is about maybe 20 lines of code total. It's really fairly straightforward. And actually, let's just break down, now that we've understood the API for DataLoader, let's look at CouchDB as an example. So once we've created our CouchDB, and that's really the first few lines of this is really the whole DataLoader API here. Really, all this is defining the batch function. Down here is where we're going to actually use our data loader. And so this is what our keys are going to be. These are CouchDB keys. And CouchDB is a key value store kind of database. So here I'm loading two different promises, promise 1 and promise 2. And what's going to happen is at the end of the frame of execution, we're going to call the batch function. So keys is going to be the array that includes these two keys here. And what we're going to do is return a promise. And this is how you construct an ES6 promise if you haven't seen that before. That lets you resolve or reject the promise. And in here now we are calling CouchDB. So UserDB is the CouchDB table that we pulled out of our Couch instance, and we're going to fetch. And the cool thing is that CouchDB already has a mechanism for batch loading. And in fact, most databases already have this capability, and we just want to leverage it. So CouchDB has this ability to fetch by keys. And we're just going to pass the keys in that we got from our batch function. And when fetchdb is finished with its load, it's either going to give us an error or it's going to give us back the CouchDB documents that it loaded. If we get an error, then we're going to reject our promise with that error. Otherwise, what we're going to do is we're going to resolve our promise. And what we're going to do is we're going to make sure that for the promises that are errors, we actually want to return JavaScript error objects. And that's going to make sure that those specific promises are errored rather than having to error the entire batch of promises. And so that's all this line is doing here, is it's saying for every document that we got back from CouchDB, did CouchDB tell us that it was an error? If so, then we want to return an error object. Otherwise, we want to return the document itself. And so that's it. So we're resolving here an array of the CouchDB documents, or errors in the case that they failed, given this array of keys. And what DataLoader is giving us back is this user loader object that we can call .load on, given a key, and it's going to return to us a promise. This example is kind of contrived because obviously we could have just called the batch function directly if we were going to do this. But this is really valuable when these two pieces of promise loading occur in unrelated parts of your application that really shouldn't know about each other. Okay, so that's DataLoader, that's the API. Let's dig in and see how it works. So the first thing that you'll notice when you look at the source, and this is just, there's one file to DataLoader, it's just in the source directory, index.js, is that we're using flow type. Flow type is super cool. I won't go into depth too much on why you should use flow type, except that you should. And if you're not using flow type, use something like TypeScript or something like that. I'm a huge fan of these layering types on top of JavaScript. So the first few things that you'll see are types that we're going to define that we're going to use throughout the rest of our code. These basically get compiled out when we actually build a file that we can run in Node, but it's useful for Flow to understand what's going on. So the first one here is our batch load function. And here we're just defining that for some type K, that's going to represent our keys, and for some type V, that's going to represent the values that we ultimately return. A batch loading function is, as we said before, an array where you give keys. That's an array of some key type, usually strings or numbers, and it's going to return a promise. And that promise is going to resolve to an array where the value is either going to be a value or it's going to be an error object. There's some other types in here for what a cache map is. This is basically the simplest definition of ES6 map. And then our options, and this is as we referred to them before. So here's the DataLoader function. It's a class, and we construct it. I'm just going to do a cursory overview first, and then we'll dive in. Here's our load function, where we provide a single key. That's that key type again. Just imagine that's probably going to be a string or a number for you. And that's going to return back a promise of a value. Notice up here before we said our batch loader function is going to return a promise of arrays of values or errors, but our load function is only going to return a promise of the value. That's because if you return an error in your batch load function, we're going to make sure that turns into a rejected promise, because that's what you want. Likewise, there's this load many. As you can see, it truly is sugar for promise.all, and clear all, which just address the cache. Down here is the implementation of the guts, and we'll go into this last. And so this is for those who are really interested in exactly how we're scheduling this stuff. I think that's pretty interesting, but we'll do that last. So first, let's look at the constructor function of DataLoader. And that's the thing that takes in your batch loading function and then some options if you got them. As you'll notice, this file is fairly short. Scrolling down all the way to the bottom, 270 lines total. There are a lot of comments in here too. So there's really not too much going on in this file. That said, there's some fairly complicated techniques going on. It's just that they're fairly dense and simple, which is why there are only a few lines of code. So the first thing that we're going to do is kind of pull some stuff out of our options object. And that's just to make sure that if you don't pass an options object, that we're going to do the right default. Otherwise, we're going to read what you gave us. And we're going to get your cache key function if you got one. And then we're going to, if we're caching, we're going to create a cached promise. So what that does is it's going to look in this cache. And we'll get to this a little bit later in when we actually put something into the cache. But this handles caching. So we're not actually caching values. We're caching promises. So given the key that you gave us, if we've already created a promise for that value, we're just going to return that promise to you directly. All right. So say that that isn't the case. This is a new key that we haven't seen before. Well, we're going to need to create a new promise. We're going to create a promise. And here's its functions for resolving and rejecting that promise. And the first thing that we're going to do is we're going to add it to a queue. The queue handles all of the promises that we know about that we haven't run yet. And when I get to the end, we'll see exactly what it is that we're doing with the queue. But suffice to say, we're getting all of these things, we're tacking them onto the queue, and later we're going to run that whole queue as a batch. each item in the queue is a tuple of the key that we want to load and the resolve and the reject functions for a promise. The next thing that we want to do is determine whether or not we need to tell our scheduler that we actually need to run one of these batches. And the only thing that we do there is just determine, is this the first thing that we've pushed into the queue? So that way, if we've added something in and it's the second or the third thing to the queue, we don't want to tell the scheduler that it has to do work more than once. But at some point, we need to tell the scheduler, hey, at some point, you need to take the queue, you need to figure what's in it, and you need to run a batch. So that's what's happening here. So if this queue's length is 1, which is going to be the case if this was the first time we push something into it, and we're batching, which is really important, then we're going to call this thing in queue post process job. This is the thing that we're going to get to at the end. So that's really all there is to it. When you create one of these promises, all you're doing is tacking something onto the end of the queue and then kind of moving on. So there's really not that much happening when you're loading a single object. Here we are at the end of this function. If we're caching, then we want to put that into the cache. That way, when we come back up here, when we load something back out of the cache, we'll get it, right? Okay. And then we're going to return that promise to you so that you can call then on it. Load many just calls promise.all. Clear. So when you call clear, you give it a key. And for convenience, it's going to return itself. And what clear does is if we're caching and we're going to get our cache key and we're just going to delete from the promise cache. Now, if nothing's there, nothing will happen. But if there was something there, then we're going to take that promise out. That way, next time we call load, we're going to create a new promise. And again, this is important if you are doing some mutation somewhere and some key that may or may not have been loaded before would be invalid. You want to make sure that if a subsequent load happens, that it's going to get a fresh copy. And clear all just literally clears the entire cache. That's all that's happening there. All right, now we're going to get to the meat. This is where stuff gets cool. So as you can see, we're in the land where we're writing more comments than implementation. And if you look at here, there's going to be some jargon that's pulled directly from the specification for JavaScript or ECMAScript. So ES6 introduced a really cool new feature that makes promises actually work, and it's called Microtasks. So how Microtasks work is at the end of a run loop, there's a microtask queue, and JavaScript will run all the tasks in your microtask queue. Now, right now, there's only one kind of queue, and that's the promise jobs queue. In the future, there may be more queues, or there might even be an API for creating your own kind of queues. Right now, that's not the case. So what we want to do, if we want to do some work after the frame of execution is done, we need to do it in terms of a promise in order to do it when the stack kind of unwinds. So if you're ever curious, when does my promise actually run? It's at the end of the frame of execution and before the next frame of execution begins. Okay, so in queue post promise job, what we want to do here is, given some function, we want to run that function after our promises have run, which is what I mean by post promise job. And now that's a little bit tricky because, as I said before, promise jobs is the only queue that we have. So what we actually want to do is tick once and then run. So process.nextTick is Node's implementation for giving you the opportunity to put something into this micro task queue. And so that's all that's happening here. Resolve promise, this is a little bit of a hack. What this is saying is I want to next tick after my promises have ended. Node is a little bit special, and it has two queues. It has the promise jobs queues, and then it has kind of everything else. And when you call promise.nextTick, you kind of tack it in with everything else. If I called promise.nextTick without this promise step, it might run before I run any other promises. The reason that I care about that is I want to make sure when I'm batching things that don't just happen during my frame of execution, but also those things that occur during promise resolution. That's important because as people start writing async await code, and then you're going to await something, you're going to get some value, you're going to load again, you might use DataLoader to do that. We want to make sure that we're batching all that stuff together. And because that stuff is happening during promise resolution, we want to make sure that we're running our batches after that stuff happens. That's all that's happening here. And this is micro optimization to make sure we only create one of these one time. Okay, dispatch queue is another thing. Going back to this thing up here, note that this is entirely generic. There's nothing about DataLoader happening here. This function doesn't call out to anything that it doesn't already exist in JavaScript. Dispatch queue and in queue post promise job, these two things are related up here where we did this. So we're going to enqueue a job where we dispatch the queue for this data loader. All right. And note that if we're not batching, we just dispatch the queue right away. We don't enqueue a job or anything like that. All right. Dispatch queue. Dispatch queue is by far and away the largest piece of code in here, but it's still fairly small. I mean, really, most of the lines of code here are well-written error messages so that if you do something a little askew, we can give you as much information as possible. All right, so let's look at this. Dispatch queue's job is to take a data loader, one of these data loaders that we created before, take its queue, and then take everything in that queue and run it as a batch. So the first thing that we're going to do is we're going to take that queue off the loader, and we're going to set that loader back to the empty set. Now that's important because during the run of the loader, it might call itself, right? So say you want to load a user, and then you want to load that user's friends. You could have a loader that calls the same data loader again, right, for the same type of information. So we want to make sure that we empty the queue right after we grab onto it, so those things tick and create a second batch rather than creating an infinite loop. All right. Once we have that queue, and remember before, what we were putting into our queue was this tuple where it's the key that we wanted to load and the resolve and reject functions for our promise. Those are the three things that went into the queue. So the first thing that we're going to do is we're going to get the list of keys. And the way that we can do that is for every item in the queue, we take the key and we add that to this list of keys. So now keys is an array of the keys that we provided to our load function. And that's exactly what we wanted to add to provide to our batch load function. So that's what's happening here. We're passing keys directly into our batch load function. And that's going to give us the batch promise. So that's your job, right? As implementing a data loader or using the data loader API, you're going to take in this array of keys. You're going to return back to us a promise for an array of things. And that's why these error messages are here. We're going to make sure that you will uphold your part of the deal. So, if you don't return to us anything, or if you return us something that doesn't have a then function, then we're going to make sure that we fail the dispatch. And I'll show you a little bit about exactly why we factored out into its own function in a minute. And we're going to fail it with the error that tells you exactly what we expected you to give us and that we didn't see a promise. All right. So provided that we get past that check, then we definitely know we have a promise. We then the promise, which means when this calls back, we're going to get our list of values. And the first thing we're going to do, again, we're going to make sure that you're upholding your side of the bargain. We're going to make sure that you gave us an array. And if you don't, then we're going to give you a clear message describing what happened, that we didn't see that array. And the next thing that we're going to do is make sure that the list of the values that you gave us is the same size as the list of keys that we gave you. Because if that doesn't line up, then we're not quite sure what's happening and it's probably not safe to proceed. So we're going to check that too. And we're going to tell you what the keys and the values we got. So hopefully you can use that as debugging information if that were to happen. And finally, after all this error checking, we get to the meat of this, which is really actually pretty straightforward. So we're going to take that queue. That's our list of key, resolve, reject tuples. We're going to loop through it, and we're going to keep track of the index as we go. So for each one of these things, we want to get the values out of the returned list that you gave us. So now we have both the key and the value. And here's where we're checking for that error. So if you gave us an instance of an error, then we want to reject the promise. And this reject function is the reject function that we put into the queue. So that's the reject function for that one particular promise that we created. And we're going to reject it with the error. Otherwise, if you gave us something that's not an error, then we're going to assume that things went well. We're going to call your resolve function with the value. And now here, after the then function, is our catch. So if anything went wrong, either during your batch load or during our calling reject or resolve or throughout any of here, it's going to fall through to this catch block. We're going to get that error, and we're going to fail the dispatch. So note that here we're just calling reject. We're rejecting your promise. Here we're calling failed dispatch. And failed dispatch is getting called in two places. Here, where you gave us something that didn't quite work, and down here. That's why we factored it out, because we're calling it in two places. And that's the last little bit of code in here, is failed dispatch. So what failed dispatch does is we want to take our queue. So failed dispatch gets a loader, the loader that we care about, the queue, which was the queue that we took off that loader, and then the error message of what went wrong. Those three things get passed into our failed dispatch, and we're going to loop through the queue. And for each key in the queue and the rejection, first what we want to do is we want to clear that from the loader. Because, if the whole batch failed, that doesn't necessarily mean that that one key that you loaded is erroneous or had some error occurring. It just means that the batch itself failed. So we still want to reject your promise, but by clearing it, it means the next time you go to load, we're going to try again. And so that's really nice, right? Like if we reject this and we give you the opportunity to retry that, you're not just going to hit the cache and get the same rejection over and over again. Whereas here, we don't clear the cache, and that's because you gave us specifically from your batch function an error, which tells us that for that key, the appropriate response is erroring. And so that also gets cached just like a value got cached. So if you try to load that key over and over again, we're going to return right back to the same promise that's just going to reject itself over and over again, ensuring that if you query one bad key a bunch of times, you get the same error every time. That's pretty much it. There's not that much code in here. I'll spend kind of, one last moment just kind of showing you the tests. I think that's also fairly useful for understanding what's going on. We blocked our tests into two files, the abuse test and the DataLoader test. The abuse test basically tests for those error messages that I was showing you before, where if you kind of return something, if you use the batch or the DataLoader API in a way that we didn't expect, we're going to hopefully tell you the right thing. And those are all examples of, here we call DataLoader and we forgot to provide you the right value. It's going to throw something that tells you what's going on, right? We got undefined. We were supposed to get a function, all the way down to places where, you were giving you a function, but we're returning null, or we're not returning a promise, or we're returning a promise, but that promise is empty. Just all the different cases where you might do something and, not by accident probably, but we want to make sure that we give you the right debugging information to figure out what's happening. DataLoader test. If you ever want to figure out all the kind of edge cases of what can happen in the library, just check out the tests. As I was saying at the top, I'm kind of proud of the fact that this library has 100% test coverage, even though the library is only, less than 300 lines of code, including copious comments and error messages. Despite that, there's still more than twice as many lines of code just for the usage tests, and then another 150 lines of code for our abuse tests, API abuse tests. That says something about, just how much you need to test all these edge cases in order to figure out all the weird, quirky stuff. And this tests things like making sure we can clear values, making sure that we can accept any kind of key, including our options to provide our own cache keys, and making sure things come back in the right order. So you can check that out if you ever think there might be a bug. Hopefully we've already written a test for it, and if we haven't, definitely please add one. All right, so that's it. Going back up here, that's DataLoader. So hopefully this has been interesting. First talk and what I hope will be a handful of these talks. In the future, I won't dedicate an entire talk to one topic, but I hope that DataLoader is simple and straightforward enough that it was useful to have it in one fell swoop. So if this has been interesting to you, please let me know. It takes some of my time and energy to do this, and it's fun, but I want to make sure this is valuable to the folks that are watching. And if you have questions or comments, please drop them in the comments below on YouTube, or send me a comment on Twitter. I would appreciate it. Thank you guys, and until next time.